Hi, this is Robert, and I wanted to jump into my next, or eventually next project. And I've got the pass amp bug now, and so my next project, or at least that project or the one immediately after, will be Nelson Pass's F6 amplifier, and done a number of things here. I've copied the Nelson Pass article that he published in 2012 discussing the design philosophy of the F6, and then I've also gone to DIY audio. This article was at the First Watt website. And I've also gone to DIY audio, and as always, they have an excellent illustrated build guide that 6L6 did. And there's a BOM or bill of materials at the end of it. Tells you what you need to order to build this project. And there's also, in the build guide, there's a example of the most current schematic diagram for it. You can see it was a bit too big for my printer, so I had to add the positive supply line to the top there. This it's an interesting amplifier, and I've been told that it sounds very tube-like, so of course that's intrigued me quite a bit. And I could see why, because it's a rare beast. It's a solid state, again, Mosfet output amplifier, JFET input amplifier. Those are the two amplifying stages, JFET in, Mosfet out. But there's a twist to it, and there's a third amplifying stage, or at least there's voltage gain being done by this stage, and that's this Interstage Transformer that Mr. Pass is using. Here's one of them right here. It's a little Jensen guy, has 8 pins on it. But the signal comes in, and this part up to here looks very much like the F5. You have the complementary JFET pair, you have the same input circuit, except that on the sources of the JFETs, excuse me, you have the input windings of the transformer. There's actually 2 windings, one for the plus phase, one for the minus phase, and their secondaries are over here driving the input of the MOSFETs. Here's the other, and it's driving that MOSFET. And then about the only other thing you have in this amplifier, there's a source resistor. There are a pair of source resistors, and you have a bias circuit for each MOSFET. That's done by the zener diode and a potentiometer. Again, zener diode potentiometer going in. The interesting thing is, because the transformer is doing the matching from the input to the output, it's also, you can use it to invert polarity. You notice with the plus mark here and the minus mark here. So this one, Q2 is going to be driven in opposite phase from Q1, which is very cool. This is again a circuit more like what you would see in a tube circuit. So I'm intrigued by it, to say the least. What I wanted to do is start stuffing a board. Nudge this down a bit, that will go. Here's one of the circuit boards, and they're very simple. There are two MOSFETs per channel. Input FETs, the transformer sits here. You have a pair of offset bias pots. Oh, this one does say offset, but they're both bias pots actually. Although, if you watch my F5 biasing technique, you know why they call one bias pot an offset pot, kind of how they work in a way. But anyway, what I thought I would do is maybe kill two birds with one stone and give you a little soldering primer. We'll see. So over here I have my iron. I've got a well-used tip on this iron, and I clean it with a sponge. A clean soldering iron is half the battle when you're soldering. Newcomers make a lot of mistakes, so there are three things I want to talk about. 1, keep a clean iron. 2, you're heating the soldered joint. You're not heating, or let me put it this way, you're melting the solder on the solder joint, not on the tip of the iron. That's how you get a cold solder joint. Third, which I've forgotten at the moment, is to make a good mechanical connection before. A good mechanical connection will ensure a good solder connection. So let's go ahead and start stuffing parts. Now I've got a large Mouser box on the floor here. The first part I grabbed were the 47.5K resistors. That's R6. So I usually just take them and I turn the value up. You've got, it'll say Dale, and then RN60, and then here you go, 475 to the second power is the value. And these you can pretty much just bend on your own. This is going in R6, so we hunt down R6. Now there it is. And one thing we have to watch out for is, see, oh, I've got it the other way. I want it to go the same way as the labels on the circuit board, so we'll do it that way. And then I bend them over on the back like that, hold them in place. But what I was about to mention before I got distracted is that the circuit boards are different. There's a left board and a right board. And that is so when you mount them in the amplifier, they're actually going to go like that. The transformers are as far away from the input transformers on the circuit boards are as far away from your power transformer as possible. That way there's no coupling between them. So now I've got my other board here, and R6 is down there now. Put it on. Isn't this exciting? Need to be real careful. I don't want to knock the camera off the dining room table here. Just bend those flat, and we're 2 down now. So the next one I pick up is the 18 ohm resistor, which is R4 on each of these. So I'll grab 2 of those. But these are Dale RN60 1%. They're my favorite resistor of choice. R4 is right there. And see, here R4's up there. When you're stuffing the board and soldering it, it's best to start with the components that fit closest to the circuit board and work up to the tall stuff. That way the tall stuff isn't blocking your access to the shorter stuff when you're trying to build something. Next we have the 1Ks, 1 or 10. R5 is 1K. And you thought my last video was boring. So I try and put them in the board with the printed value of the resistor pointing up. So it makes troubleshooting a little easier. Because all these resistors are going to say Dale RN60 on them, but what makes them unique is the value, the identifier. So we now have 10K ohms, which we have a bunch, 4 per board. So let's pull a bunch out here. 1002F, so R7. R8, which is over here now. Then R9 and 10. Concern for this tip. You don't want to have your tip just sitting there burning away. So I'm going to put a blob of solder on it, keep it from degrading too much. As it is, it's on its last legs. So we have R9 and R10 is there. Again, R7 here, R8 over here. Now resistors have no polarity, so you can put them in either way. I just tend to do it, I like to keep things very neat, ordered, and symmetrical. So we have R9. Is there. And so I'll always try and put them in so that when you're looking at the board, all you see, you can hold it in one direction and read all of them easily. I've been doing this for a while, so I've hopefully I won't show you any of my bad habits, but hopefully you might learn a good one. I think I have 1 or 2 of those. So let's see. I think some of these values I'm going to have to rifle through my big bag of parts here. See what I've got. And put in a zener diode, which is a different animal. These are zener diodes. You notice they have a black band on the left-hand side that designates the cathode, which if we look, I need a pointing stick. Here's our zener diodes symbol. It's a triangle pointing to a zigzag line. That zigzag line is the cathode side. You can see there's another one over here. So I'm just going to cut these out. It helps to have good tools when you're working with this stuff. Now this is one case where I'm not going to bend the leads. These have nice copper leads. I think these are actually, where'd I put that thing? Somewhere I have a test magnet. Somewhere I did have a test magnet. Oh well, it appears to have migrated. Anyway, these I believe have steel leads, but you don't want to bend the lead right at the body of the unit. That tends to put a lot of mechanical stress on the unit. So what I've done is I'm holding it with my needle nose pliers and then bending the diode away from that. That reduces the mechanical stress on the diode itself, because these are made with glass and they're fairly fragile. Also, being semiconductors, they are temperature sensitive. So that's going to go in like that. Fits flat to the board. Again, bend these out. At this point, they're not going to hurt the diode. Now, both cathodes face down on this board. We'll do it again for this one. There went my tripod. I'm glad I didn't have the camera on it. I thought about using it on the table. It's a little too big and tall, so again, I'm using a kind of a makeshift little stand to hold the camera in place. I wanted it low down and in the action. Hopefully you are seeing some action here. Again, cathode down, stripe to stripe, band to band. There it goes in. This one's not perfectly in line, so I'm going to have to tug it through. There it goes. Now it's sitting flat. And this one goes the other way. Interesting. Double check that. Yep, I can see the cathode bands on the board. Yeah, this one fits in much better. It's still a little high on this side, so kind of ease it up on the other side and pull it down. Okay, let's see, I think there's one last thing I wanted to mount on the board, if I can find them. Oh, what do we have here? Okay, the blue LEDs. See, you notice it says LED blue. It's got to be blue if it's a pass device. What they don't give us is much of a polarity thing, so I'm going to have to look into that. That'll have to wait for a bit. But I'm going to go ahead and put in the bias pots. Here they are. Actually, these should wait too, because I'll want to zero them out before they go in the board. So never mind. We'll just do some resistor soldering. Ideally, it'd be nice to have some way to prop this up a bit so you can see it better. I'm using Cardus solder, which I like. Flows incredibly well. It melts relatively quickly, and so it gives you few issues when soldering. So it kind of spoils you. So the important thing when soldering is to heat the joint first. You put the iron on the joint, then apply solder. Not onto the iron, but onto the joint. Same thing. I'm trying to get on both that lead and the land on the circuit board. Apply it. You notice I'm feeding the solder into the joint and not into the soldering iron. Same thing over here. I'm going to clean it. It's still looking a bit nasty. There. Feed the solder in. And these are resistors. They can take a little heat, so you can let it sit and bubble if you want. Let the solder flow. The heat and time is your friend for the most part. Now this is the diode. I don't want to do it yet. We'll do it last. So you can hear that creaking noise. That's the iron heating the joint up, or losing heat into the joint, I should say. Looking dirty again, so clean it. So you can wait a little bit to let the joint heat up, apply the solder, keep heating the joint up a bit. I'm going to move that over so I can reach this. And ideally what you want is a nice shiny joint with smooth curves, either looking kind of like a Hershey Kiss, where it's a concave cone. Let's move over here. Hopefully you can see all this. Would suck if you can't. Okay, now I'm going to do the two diodes. So I'm going to apply heat, count to 3, and apply solder. 1, 2, 3. 1, 2, 3. Semiconductors are heat sensitive. You can burn them up if you're not careful with a soldering iron. So the idea is to have a hot iron, get it on there, heat the joint, 1, 2, 3, melt the solder, 1, 2, 3, let it flow, get the heat off of there. Look at that. It's got had a piece of old solder it picked up on the sponge. 1, 2, 3. 1, 2, 3. If you're really concerned about this, you can get little alligator clips and pin them onto the diode or transistor between the solder joint and the body of the part. to where they can dissipate the heat before it gets to the part. 1, 2, 3, 1, 2, 3, off. So now if I've done this well, you should see that most of the joints have a nice little solder flow on the top as well. If they don't, it may be the lead blocked most of the passage, or there may be a large land on the top that was pulling heat out of the joint. So again, we'll do this one. I'm going to move that out of the way so I can see my other solder holes. Yeah, this tip is just about ready for the dumpster. Somewhere I have another, but I'm too lazy to hunt it down wherever it is. And heat the joint. You can count to 5 if you want. Then melt the solder on the joint, not on the iron. Now these parts all solder fairly well because they're pre-tinned. They have a layer of solder on them. And they're most, the Dale resistors, I believe, use copper for the leads, so they conduct the heat fairly well. Okay, we're back to the diodes. So again, clean iron. Good contact with the joint. 1, 2, 3. 1, 2, 3, off. Contact the joint. 1, 2, 3. 1, 2, 3, off. Now, the way I've heard it described, most semiconductors can withstand the heat of a soldering iron for about 10 seconds. So you notice I'm trying to keep my exposure of the part to heat to half that, just to be on the safe side. The last thing you want to do is spend a lot of money on expensive parts and then burn them up. It's very depressing. So this is a diagonal cutter. And this one's made by Exolite, which is a company. I think they're owned by Weller. Forget. But anyway, Weller makes the soldering iron I use. There are a lot of good irons out there. A lot of people swear by the Hacko irons. If you're going to do, that's kind of there. You're going to do a number of electronics projects. If you find this interesting somehow, I would urge you to buy some decent soldering tools. Now you notice I'm trying to hold the part when I cut it. That's because these can clip them and send them flying. The leads, see if you can see they can jump, and it's no fun trying to hunt them down, especially if they go under the table or into a pile of parts that you're about to use. You don't want to have to hunt it down. Okay, now these two are a little scary because they're right next to each other. And I can't tell whether they're supposed to have a connection there or not. So what can we do? We'll check it. So what you're seeing, you'll notice there's a lot of brownish deposits on the board. This is the flux, the rosin flux that helps the solder flow. And it will deposit on your board. You can clean it off with rubbing alcohol. It's no big deal. I'll normally do that when I'm done soldering everything. But you do want to, unless you're going to use one of these connections as a test point, and you want to cut these leads very short so that you're not scratching yourself against the boards when you're working on the amplifier. So again, let's see. If I see any yeah, I don't see any bad connections. So somewhere I'm supposed to have 110 ohm resistors. I hope I didn't get back ordered on them. And I have some nice huge capacitors here that will I'll eventually mount. But again, this is where you can have issues. Because all of a sudden now you're having to reach around this big old part, and you know you run the risk of burning it with the iron. So it's best to hold off on those. Start with the low parts, get them all installed, and then go to the higher up parts. So I'm still not done with my resistors. Which brings to mind an issue I wanted to talk about. Here they are. Mouser and I think I checked Mouser, DigiKey, and Newark. And it looks like they are starting to discontinue the 3-watt power metal oxide resistors in values under 1 ohm. I'd order 100 of the 1 ohms, and I'm very disappointed. These are the, they didn't have the Panasonics anymore. I had to get the Xicon, Xicon units, And my thought was, well, I'll just order 100 and I can parallel them up to get my 0.47 ohm values, or half an ohm, by putting them in parallel like this. The problem is every one of these I've tested, these are far closer to 110, or pardon me, 1.1 ohm than they are to 1 ohm. If we grab two and measure them here, hopefully you can see that. You can see they almost all are reading about 112, 113, 114. They claim to have a 5% tolerance, and this is outside a 10% tolerance. So I'm not thrilled with these parts. And sadly, that seems to be the way things go these days. You find fewer and fewer analog compatible parts. Everything is digital now. And finding quality analog parts is getting harder. I have some resistors coming from China, which honestly I'm not holding much hope for, but and today I just ordered the last 17 of the Icon 0.47 ohm resistors that Mouser had. I hope they get more in at some point, but it's getting frustrating, you know. What's a DIYer to do? Anyway, I've had a lot of folks ask me if I could provide the BOM on the F5 Turbo, and I kept saying it's on the DIY Audio website, and it's in the F5 Illustrated Build Guide at the end of the assembly photographs. You have the assembly photographs, then you have a diagram of the dim bulb tester, then you have the biasing technique, and then the very next post you'll see is a parts BOM. So it's there, and it's easy to find if you look for it. I recommend using it because they have a lot of hints as to what parts work best and so on. So I think this will do it for part 1 of this debacle, and thanks for watching, and I'll talk to you later.